Hi students, welcome to my lectures on chemical reaction engineering. As we are discussing about the kinetics of different kinds of reactions, and today we are going to discuss about the kinetics of autocatalytic reaction. These are the reactions are a bit dangerous in sense because the speed of the reaction is very fast, and the autocatalytic reactions are those in which one of the product itself is a reactant, right? Yes, because A plus R gives rise to R plus R. R is my reactant as well as R is my product. That means during the reaction the product is continue to form, and because of the product reactant concentration is also increasing. That is why as the reactant concentration is continue to increase, the rates are very much high in terms of autocatalytic reactions. For example, the reaction A plus R gives rise to R plus R. You can see R is my product as well as R is my reactant. Every 1 mole of R is reacting to produce 2 moles of R. That means during the reaction 1 mole of R is producing 2 moles of R. That means the product concentration is rising as well as the same product is reactant in my reactor. So the product concentration is also maximum and the reactant concentration is also reaching maximum. When the reactant concentration is continuously increasing, the speed of the reaction will also increase, more. Okay, that is why we have to deal carefully with the autocatalytic reactions, because the reactant concentration remains high, because because of that we have to be careful. Let us go in today's lecture to find out the concentrations of A, concentration of R and the speed of the or rate of reaction. To do that we have to follow the set of procedures, and the first thing is I know minus Ra equal to minus dCA by dt. We know the rate of reaction, rate of disappearance of A is nothing but K times Ca into Cr. And to do that we have to do a different mole balance also. Imagine at any point of time the total concentration in the reactor is because of the two reactants, one is A and one is R. So that is why the total concentration any time is nothing but initial concentration of A plus initial concentration of R, because R is also necessary to start the reaction, which is equal to Ca plus Cr. Ca is the concentration of A at any time during the reaction and Cr is the concentration of R at any time during the reaction. But total concentration, because there are only two things, either A or R. So that is why total concentration is combination of Ca plus Cr. At the initial stage the total concentration is Ca0 plus Cr0. After the reaction the total concentration is nothing but remaining reaction of reactant A and remaining reactant and product, which is R. So that is why this equation holds for this reaction. So let us proceed. From this you can get Cr is equal to Ct0 minus Ca. Once you substitute in place of Cr, the equation number 3, you have K times Ca into Ct0 minus Ca. Now you have to integrate, right, because now everything is in terms of A only. So it is easy for us to integrate. So take all the terms of concentration on the left hand side and remaining terms on the right hand side. You get minus dCA by Ca into Ct0 minus Ca is equal to K times integral 0 to T dt. Ca at time t equal to 0, the initial concentration is Ca0, at time t equal to t, the concentration of A is Ca. Now we can do a partial fraction method. So take this term and divide it into two simpler expression to integrate it in a easy way. So 1 by Ca times Ct0 minus Ca is equal to A by Ca plus B by Ct0 minus Ca. Now take out the common factors, multiply the A into Ct0 minus Ca and B times Ca, you get this equation. Now you can see both the denominators are the same. Now equate the numerators. If you equate the numerators, 1 is equal to Ca into right Ct0 minus Ca plus B times Ca, right. Now equate the coefficients of Ca and constants, you get the two equations. From two equations you get A and what is B. And if you see on the left hand side, there is no coefficients of Ca, that is 0, and on the right hand side the coefficients of Ca is minus A and B. So that is why 0 equal to minus A plus B, therefore A equal to B. Let us equate the constants. There is one constant on the left hand side, another constant on the right hand side is nothing but A times Ct0. So 1 is equal to A times Ct0. From this A equal to 1 by Ct0. If A is 1 by Ct0, A equal to B, that is B equal to A is equal to 1 by Ct0. Now you got A and B. Simply substitute in this equation. You get 1 by Ct0 times by Ca plus 1 by Ct0 times Ct0 minus Ca. Take out the common Ct0, 1 by Ct0, and you get 1 by Ca minus 1 by Ct0 minus Ca. Now put this expression in place of total integral, then you expand the integral, and you can see and you take out the 1 by Ct0 and send it to the right hand side. Integral of 1 by Ca is nothing but ln Ca, integral of 1 by Ct0 minus Ca is nothing but ln Ct0 minus Ca. Limits Ca 0 to Ca, here is Ca 0 to Ca. Once you substitute the limits, that you get ln Ca by Ca 0 plus ln Ct0 minus Ca by Ct0 minus Ca is equal to k times T into Ct0. Now if you rearrange the equation, you get ln Ca0, ln A plus ln B is equal to ln A into B. So Ca0 into Ct0 minus Ca by Ca into Ct0 minus Ca0 is nothing but k Ct0 into T. Now you can see it is in the y equal to mx linear equation. This is entire y, the slope of this is k into Ct0 into x is nothing but time. That means if you plot the ln expression on the y axis, the time is on x axis, you get the slope is nothing but k times Ct0. If you know the slope, you can get the k, nothing but slope divided by Ct0 is nothing but k. Now if a reaction which is happening in the reactor is autocatalytic reaction, then it has to form a straight line, all the data points, and it can be connected with a one straight line. If you can able to do that with 99% accuracy, whatever the model you have assumed, and that is correct. And let us, I have conducted example, we have conducted, we have the data for the autocatalytic reactions and reactor, and the initial concentration of A in the reactor is 50 mole per liter, and the initial concentration of R is 100 mole per liter. And what is Ct0 is nothing but Ca0 plus Cr0 is equal to 150 mole per liter. Now with the time, every 2.5 minutes, time is in minutes, I am sorry, this is time is in minutes. Every 2.5 minutes I have taken out the sample and I have measured what is the concentration of A in my reactor. At time t equal to 0, my concentration is A is the initial concentration, at the time the ln value is 0, because if I know the Ca0, I know the Ct0. If I because Ct0 from here, Ca is 0 from here, Ca from here, now I can evaluate the value of ln. So at 2.5 the value is 0.37. Like that, at different times I have taken samples from the reactor and I have got the ln values. Now what I have to do is plot ln of this expression on the y axis, time on this axis. Finally I get the slope. From the slope I got the value of k is nothing but 0.001 liter per mole per minute. Okay. Sorry, this is second order equations, fine. Liter per mole per minute. This is the rate constant. Now this is how we can able to get the rate constant for this equation. Let us proceed to find out what is the difference in the normal reaction and the autocatalytic reactions. Let us find out the speed of the reaction. At different times I have the different concentrations of A, and what is the concentration of R? The concentration of R is nothing but total concentration minus Ca, that is the total concentration minus Ca. So Ct0, I know Ct0 is 150, I know Ca, I know CR is nothing but C20 is 150 minus 50. Now, what is my speed? Is nothing but minus RA is equal to minus dCA by dt is nothing but K times CA into CR. That means during the starting period, what is the speed? 0.001, which is the value of the K, into CA, which is 50, which is into CR, which is 100. The speed is 5 mole per liter every minute. That means the concentration of A will reduce 5 mole per liter every minute. Okay? That is what. And observe what is happening of the next time. At after 2.5 minutes, what is my concentration? Is 38.3. That means A is getting reacted. So, the concentration of A has been dropped. Look at the R. R is also reactant as well as a product. R initially it is 100 mole per liter. On the second instant, the concentration of R has been raised. That is 111.7. 100 to 111.7. That means because of the reaction, because 1 mole of R is getting reacted, 2 moles of R is formed. That means if you start with some R, you will get to see, because of the progress of the reaction, the concentration of R will continue to rise. So, that is why at different times the concentration of A is dropping, the concentration of R is rising. The speed, I mean it is speed, you can see check the speeds. Okay. Initially it is 5, it is 4.2, 3.4. Even though R is forming, the speed is also decreasing. Why? Because of the concentration of A is decreasing. Finally, RA equal to minus dCA by dt K into CA into CR. Now, if you see the drop in the speeds, if you consider first order, second order equations, the speed has been drastically dropped. Okay. Here the speed will not be drastically dropped. Initially it is 5, after 2.5 minutes the speed is 4.27. If you check my earlier lectures, check the case of what is the speed of the first order and second order. So, here we have to be very careful for the autocatalytic reaction, because the concentration of R is continue to rise, because if one of my concentration is continue to rise and the speed of the reaction is also remains high. Okay. That is why we have to be careful with the autocatalytic reactions. This equation, I hope you understand what is the different scenario for the autocatalytic reaction. Let us a bit small further, I mean into the equations. Here we have seen in terms of concentrations. Now we will same equation how it looks like in terms of conversion. Let us do that. Let us see how the same equation looks in terms of conversion. Okay. I know Ca is equal to Ca0 into 1 minus x. Okay. What is my Ct0? Is nothing but total concentration of A plus total concentration of R. What is phi R? Nothing but initial concentration of R divided by initial concentration of A. If you know these terms, let us how the numerator will change, how the denominator will change, how the right hand side expression will change. So, once we substitute numerator, denominator and right hand side expression, we will get an equation in terms of conversion. Let us take the numerator Ca0 into Ct0 minus Ca0. Okay. That is nothing but Ca0 into what is Ct0? Ca0 plus Cr0. What is Ca? Ca is nothing but Ca0 into 1 minus x. Now, Ca0 get cancels out, and you can see Ca0 into Cr0 plus Ca0 into x. Now, if you multiply numerator and denominator by Ca0, it becomes Ca0 square into, take out, one more Ca0 as a common, you get Ca0 square into Cr0 by Ca0 plus x. I know Cr0 by Ca0 is nothing but phi r. So, the entire numerator is nothing but Ca0 square into phi r plus x. If you take out the denominator, that is nothing but Ca into Ct0 minus Ca0. If you do the similar way, Ca is nothing but Ca0 into 1 minus x plus Ct0 is equal to Ca0 plus Cr0 minus Ca0. Finally, Ca0 into 1 minus x into Cr0. If you multiply numerator and denominator by Ca0, and becomes Ca0 square into 1 minus x into Cr0 by Cr0, and that is nothing but I know Cr0 by Ca0 is equal to phi r, that is Ca0 square into 1 minus x into phi r. Now, I got the numerator, now I got the denominator. What is the right hand side expression? Is nothing but Ca0 plus Cr0, I know from this take out CA0 as a common from this expression. So, that it will become CA0 into 1 plus CR0 by CA0 into k times t, nothing but CA0 into 1 plus phi r into k times t. Now, I have got the numerator, I got the denominator, I have the right hand side expression. Simply I substitute the values of 11, 12, 13, that means 11, 12, 13 in equation 10, which is nothing but this, you are going to get ln phi r plus x by phi r into 1 minus x is equal to CA0 into 1 plus phi r into k into t. Here again you get the equation in terms of straight line passing through origin y equal to m times x. If you plot this ln expression on the y axis, the time is on x axis, whatever you have got here is nothing but slope. Slope is nothing but CA0 into 1 plus phi times x into k. Therefore, k is equal to slope divided by CA0 into 1 plus phi r. Hope you have learned the how to evaluate in terms of conversion, and a few minutes before I have explained you about how to deal with the expression in terms of concentration. And thank you very much for your patience, and let us meet up with the new lecture. Thank you.